Hello everyone, welcome back to my channel. In today's session we will be dealing with topic probability. So I am trying to combine 11th and 12th probability together and give you a vast view on probability. So let us first understand some terminologies that will be used in this, and I also will be solving few JE problems which won't be much difficult. You will get to know as we go through the session. Now let's understand this term, which is a new introduced term because in 10th also we had probability, but this term was not introduced. So the first term is mutually exclusive events. Now, as the term suggests, mutually exclusive, separate events. So this is the definition given here. You can go through it. So in simple terms, what does it mean is no two or more of them can occur simultaneously in the same trial. For example, I am telling you, let's say rolling a die. You're rolling a die. So event E is getting even number and F is getting odd number. They both cannot occur together at a single rolling of a die, right? So when you list the elements here, and when you list here, you will see no elements will be same. You won't have any favorable outcomes of both of them being same. Getting even number will be 2 4 6, odd number will be 1 5 and 3. So the intersection will be 0. So if I have to say, I wrote in terms of probability, that will be 0. But if I have to write just in terms of set, then I would say it's gonna be a empty set. That's called a mutually exclusive event. Those two events cannot occur at a single trial. Of course you can get an even number. Of course you can get an odd number. But that will happen only in two different trials, not in the single. Next is exhaustive event. As the term suggests, exhaustive. That means it's exhausting the whole set. What does it mean is, let's say rolling a die is the experiment that you're going to do. So event E is getting number less than 3. F is getting number greater than 2. Right? Now when you look over here, you will see that when you list the elements of E and F, their union is going to give you the whole sample space, that's S. Okay? So when you combine those two events as in union, you are going to end up with the whole sample space. Next is mutually exclusive and exhaustive events. So it's a combination of both. That means what? There are events which are mutually exclusive, so they don't have any points in common. So you can see that's written by this. Next is the union of all is going to give you the sample space. For example, let's say E1 is getting number less than 3. E2 is getting number greater than 2. Now when you look very carefully, they both are mutually exclusive. They don't have any common points, and the union of both is going to give you the whole sample space. So it's very important to know the terminologies, because in the question they will be using these terminologies, but if you don't know, you cannot get the answer. Now let's see this problem. If A and B are mutually exclusive even such that probability of getting A is given as this, B as this, then the set of all possible values of X lies in the interval. We have to say the answer now. This is a multiple choice question. Now you look here. Let's first see what is given. They have said they are mutually exclusive even. That means their intersection is null. Right? So probability of A I have given, probability of B I have given. Next is using the probability theorem that I know that probability always lies between 0 to 1 inclusive. Correct? Now let's come to this. I know that probability of A union B is given by probability of A plus B minus P of A intersection B. So probability of A union B is what? This. The reason being the intersection terms just vanishes. Now again, since this is also in probability, this will also lie between 0 to 1. That's why the sum also lies between 0 to 1, and that's how I got this thing. Okay. So now you have 3 inequalities, 1, 2 and 3. So this is for probability of A, this is for probability of B, this is probability A plus probability B. Now we have already done inequality session. If you have any doubt, you can again comment in the comment section. I will go through and try to make another video, or else you can go to the previous videos that I have made in inequality. So when you solve, you will get these 3 inequalities. Now we need to get the intersection of all. So what I am going to do is, I am going to place it on the number line and see the part which is common, and very well we can see only this part is coming as common to all. Okay, so that's minus 1 by 3 to 5 by 9. So this is the number that is coming as common to all until this. If you have doubt in this, you can again put your doubts in the comment section. I will try to clarify how can we take the common thing. Now the next question is again a multiple choice. They have given you a sample space. By looking at the points, we can say that it's an experiment of tossing the coin thrice, because each point is having 3, 3, 3, right? So A is given, getting all 3 tail, even B is also given to you, even C is also given to you. You don't have to understand what this event is as of now, because with respect to set also we have just now done mutually exclusive and exhaustive event. Now let's see what are those. Now what you have to simply do is you have to see whether the intersection is 0 or not. So when we see, you will get to know the intersection of any 2 event is empty. That means they are mutually exclusive. Now let's come to about union. You can see union of all will give you sample space. That means it's mutually exclusive as well as exhaustive. Okay. So in next session we will be dealing with the verbal description of the event and how to give a notation for that theoretically. So I hope you understood this session. Please like, share and subscribe.